Hey guys, welcome back. Today we're going to be comparing and ordering rational and irrational numbers. When we compare and order, that just means we're going to have to look at how big or small numbers are in those decimal places so that we can put them in the correct order from least to greatest or from greatest to least. We're going to use rational approximations to compare those irrational numbers. So that was yesterday's lesson. And in order to be successful in ordering or comparing these numbers, we not only are going to have to approximate those irrational numbers just like we did last lesson, but we're going to need to use place value to compare which number is larger. So the key idea here is you can have numbers on a number line represented in many ways. All real numbers can be located on this number line. This means that all irrational numbers can also be located on a number line. You can use number lines to graph and order these real numbers. So as you can see from the number line I show you guys, you can see that negative 4.5 is less than a number like negative 11 over 3. And the way that we're going to be able to tell that is by converting all the different types of numbers into decimals. So that's what I'm going to write as a note. We're going to convert all numbers into decimals. Okay, because that's the only way we can really truly compare is we just go from left to right comparing each number and we see which one is bigger or smaller. So let's take a look at the first example. It says complete each statement. I'm going to either fill in equals, less than, or greater than into each of these statements as my comparison. Okay, so this example would be what I mean by compare. If I ask you to compare two numbers, I want you to put an equal sign, a less than, or a greater sign in between them. So let's take a look at the first one, A. I want to compare the square root of 3 to just 1. Well, that means I need to approximate what the square root of 3 is. Well, 3 is between the two perfect squares 1 and 4. So the square root of 3 is going to be between the square root of 1 and the square root of 4, which means it's going to be in between 1 and 2. A good way to approximate this, again, let's see, I think I see yes here. 3 is 2 units away from 1. 3 is 1 unit away from 4. So the square root of 3 is going to be closer to 2 than it is to 1. I can guess 1.7. Let's see, I've got 49. That's 11. Drop that down. Okay, so I'm getting my approximation for the square root of 3 is actually even larger than, that should be a 2, should be even larger than just 1.7, which I don't really have to go further than that. I really didn't even need to really do that part, because if I know that the square root of 3 is in between 1 and 2, I know it has to be greater than 1, because if it were the equal to 1, it wouldn't be between 1 and 2. So the square root of 3 is actually greater than 1. It's going to be 1 point something, which is greater than 1.0. Let's take a look at B. We're supposed to be comparing 1.5 to the square root of 2. So let's do this again. I want to compare 2 to be between what two perfect squares? That's 1 and 4 again, which means the square root of 2 is also between the square root of 1 and the square root of 4. So that means the square root of 2 is between 1 and 2, just like the square root of 3 was. So I need to do a little more approximation here because we're comparing it to 1.5. So I'm going to try to get this out to the 10th as well. Now, the number 2 is closer to 1, which was 1 unit away, than it is to 4, which was 2 units away. So I'm going to take a guess at this 10th. Let's see. Let's try maybe 1.2. Okay, I'm getting 1.44. I think I can go a little bit higher. Let's try 1.3. It's even higher. I'm going to actually skip a number. Well, yeah, I'm going to skip a number. I'm going to try 1.5. That's probably going to go over. Yep. Okay, so we're between, since I skipped a number in between 1.3 and 1.5, square root of 2 is going to be somewhere between 1.4 and 1.5. Okay, but I do know that 1.5 was too much. That got me a number that was larger than 2. So it's going to be 1.4 something. There's going to be some number coming after 4, but that still shows me that it's less than 1.5. Okay, so square root of 2 is less than 1.5, or we can say that 1.5 is greater than the square root of 2. So what I'm going to do is I'm going to continue showing my work for approximating these comparisons. I'm going to do part C, E, and D, but I also on part D need to show what the decimal approximation for 20/9 is. So I'm going to do that work down below. If you need some extra space in your notes, turn to one of the pages where you have some blank space and show your work for this. I'm going to speed up the video a little bit so that you can follow along. Feel free to pause and check over your work at any point. Okay, I'm just going to show all my work down below here, and then I'm going to write the decimal comparison. In fact, I'll write it like that on A and B as well. The square root of 3 was approximately, we said, 1.7. The square root of 2 was approximately 1.4. And then I'm going to write the rest of my decimal approximations above each number. All right, so according to the work that we've calculated, I put each of the numbers above their respective counterparts. So root 3 was 1.7, root 2 was 1.4, root 12 was 3.5, 20 over 9 was 2.2 repeating, root 6 was 2.4, negative root 7 was negative 2.6, and pi squared was 9.9. So when we compare these numbers, we're just going from left to right, which of the numbers are equal, and then finding, as we move our eyes to the right, if one is bigger or smaller. So A should be greater than, B should be greater than, C should be less than, D should be less than, E is equal. We did have to round that one to the 10th. If we did keep going to the 100th, perhaps they would not be equal on that one. And then F was less than. So let's have you give this a try in your U-Try. Please convert 4 over 3, or 4 divided by 3, into a decimal. Write it underneath. And then also convert square root of 2 into a decimal and round that to the 10th to compare. Give me a less than, a greater than, or an equal sign between them. Give it a try. right, I got a second example here, a real life example. It says you're planning an art exhibit. One of the artists is a former math teacher. Each artist sent to you the heights of their paintings. You want to display the paintings from shortest to tallest. Show how you displayed the paintings. Now, this is basically ordering a set of numbers from least to greatest. But when you do this, I want to make sure once you place them in order, they have to be in their original forms, not in their decimal forms. So I have a couple of numbers that are already in decimal form. That 1.6, the 2.8, and this 2 is technically in a decimal form as well. It's really 2.0. So we need to convert this one, and this one. The ones I've boxed out in green. Those are the ones we need to convert. Okay, so I'm going to show my work down here at the bottom. 7 is between the two perfect squares, 4 and 9. So the square root of 7 is going to be between the square root of 4, which is 2, and the square root of 9, which is 3. Now I need to approximate that to the 10th, and I'm going to choose the 10th because if you look at all the numbers in the list, none of the numbers are to the 100th. Like I have 1.6, that's to the 10th. 2.8, that's to the 10th. And this 2, I could also say is 2.0, so that's really only to the 10th at most. So I'm going to approximate what the square root of 7 is to the 10th. Now 7 is 3 units away from 4, and it's 2 units away from 9, so it's closer to 3 than it is to 2, but not by much. So let's try 2.6. Okay, I got 6.76. That's pretty close. It's still a little bit under though, so now I'm going to try 2.7. There we go. So now I just kind of want to see which one's closer. See, 6.76 looks like it's 0.24 away. And then 7.29 would be 0.29 away. So since 0.24 is smaller, meaning closer, that means that 2.6 is a better approximation for the square root of 7. Okay, so I'm actually going to write that underneath my list right now. This one is 2.6 approximately. And now I'm just going to continue doing that for the rest of my square roots, for square root of 5 and square root of 2. All right, so now that I have done the work to convert the root numbers into rational approximations to the 10th, I can now order them. Okay, so I'm just going to first write what order they should be in, and then I'll place them in the list. Okay, so the smallest number I see looks like that 1.4. So that's the first number. Then 1.6. Then let's see, 2, because that'd be 2.0. Then 2.2. Then 2.6. Then 2.8. Now, I don't want you to just tell me which comes first, second, third, fourth, fifth, sixth. I want you to write them in their original forms in order so that I can see all their original numbers from least to greatest. So the first number we said was square root of 2. So I'm going to write square root 2 as the first number in the list. The second number was 1.6, and that was originally written as a decimal, so I'm going to write that as 1.6. Third number was just 2. Fourth number was square root of 5. Fifth number was the square root of 7. And the sixth number was 2.8. So that is us ordering these paintings from size least to greatest. It goes square root 2, 1.6, 2, square root 7, square root 5, then square root 7, and then 2.8. Let's have you give this a try in your second U try. Convert everything you see into a decimal. You're going to need to use the decimal approximation for pi, and then put them in order from least to greatest. All right, I've got one more example for you where you are ordering the numbers. I want to point out about this example that you might get numbers that when you simplify them or you long divide them, you get whole numbers and not decimals. So keep that in mind. I also want you to keep in mind that the directions here, pay attention to directions, say from greatest to least. So we're going to find those decimal approximations, and then we're going to order them from the biggest number to the smallest number. So I'm going to go ahead and speed up my work here. I'm going to show all my work down here below, but I need to change, putting boxes around them, I need to change all of these into decimals. So that about does it for example 3. I've also put in order from greatest to least the numbers in their original forms. I think the best way to do that is after you make your calculations, what I did was I put each of the numbers, okay, above or below in their decimal versions, and then I ordered them from least to greatest. And what I did was, since I didn't order them from least to greatest, I numbered them from least to greatest. So I labeled 1 the smallest number, 2 the next smallest. And then what I did in order to put them in greatest to least was I just counted backwards. So I listed the 6th one, then the 5th one, then the 4th one, and that just helped me order these numbers. And please, please, please notice that I wrote them in their original forms. Do not write them in their decimal versions as your answer. So let's have you give this a try in your third U try. Remember, we're taking all of these numbers, we're converting them into their decimal counterparts or approximations, and then we are ordering them from least to greatest, okay? Not greatest to least this time, from least to greatest. That's what we're used to. Give it a try. right, guys, I got one last close and check question for you just to tie together that you've learned what you're supposed to learn today in the lesson. I want you to match each point on the number line to the nearest value. So what I'd like you to do is look at these four numbers, actually calculate out the decimal versions of square root of 1, square root of 3, 19 over 20, or excuse me, 19 over 12, and 2 over 11. And then on the number line, tell me which letter that number corresponds to. Okay, show me this and I'll know you guys are, one, really versed in converting these different numbers into their decimal versions, and then also being able to order them. All right, that concludes our lesson today. We used rational approximations to compare and order those numbers. We approximated values of irrational numbers. We also converted those fractions into decimals. Really, all we were doing was trying to make decimal versions out of all of our numbers, even if that included approximating. We compared two numbers and justified which number was larger. We did that by showing our work. And when we compared, we were either using equal signs, less than, or greater than symbols. We really did the approximation of the irrational numbers in all three examples. And then we compared two numbers in example 1. Please make sure you go back and rewatch any sections you did not understand and get any help on any problems that you're having trouble with. You may now start your Google homework and have a great day.